Hi students, in this video we will recap some concepts regarding circles. Then as usual we will end off by looking at the O-level question. Right, so the first thing you will need to know about a circle is the equation of a circle. So the equation of a circle comes in two forms, the standard form and the general form. So you must be familiar with both forms and you should be able to obtain the center and the radius of a circle from both forms. Okay, so you should also be able to come up with the equation of the circle if you are given the center and the radius. Okay, so let's take a look at the equation of circle in the standard form. So as seen on the screen, it goes like this: x minus a squared plus y minus b squared equals to r squared. So the center is found by AB. Okay, so the center of the circle would be AB. All right. So for example, if let's say we have this particular question, x minus 5 squared plus y plus 2 square equals to 64. Okay, so for example, we have the equation of circle like this. Okay, so by comparison, you can see that a is equals to 5. Okay, over here, you can see that minus b is equals to plus 2. Okay, minus b equals to positive 2, so b will be equals to negative 2. Okay, so in other words, the center of the circle will be 5 minus 2. Right? And then the radius, so you can see over here on the right is r squared. So r squared is equal to 64. So r is going to be 8. So the radius of the circle is equal to 8 units. Okay. Okay, so this is how you obtain the center and the radius from the equation of circle in standard form. Right? Okay, so the equation of a circle can also exist in the general form. Instead, in fact, this general form is the more common form that you always see inside the O-level questions. Okay, so it goes like this: x squared plus y squared plus 2gx plus 2fy plus c is equals to 0. Okay, where the center can be found by minus g minus f, and the radius can be found by the square root of g squared plus f squared minus c. Okay, so let me give you an example of how this will work out. So let's say we have x squared plus y squared plus 6x minus 4y minus 12 equals to 0. So over here, we can clearly see that 2g, which is the coefficient of x, is equals to 6. So g will be 3, right? Okay, then next one, 2f. Okay, so which is the coefficient of y will be equals to minus 4. So f will be equals to negative 2. Okay, then from here you can see that over here is plus c. Okay, so c will be equals to negative 12. Okay, so the center is given by minus g minus f. Minus g minus f. So minus 3. G is 3, right? Okay, f is negative 2. So minus 2 will give you 2. So this is the center. Okay, then let's calculate the radius. Okay, so the radius is given by g squared. So g is 3 plus f squared minus c. So minus 12. So got to be careful at this part. Okay. So over here you have 9 plus 4, 13, 13 plus 12. So you get 25. So you get radius 5 units. Okay, so this is how you use the general form of the equation of a circle to find the center and the radius. All right. Okay, so now let's move on to some useful properties of the circle. Right, so the first useful property of a circle is that if you can look over here, okay, the normal to any tangent to a circle passes through the center of a circle. Okay, so what does it mean? So over here we have a couple of tangents to the circle. So tangent is okay, like similar to a tangent of a curve. It touches the circle at only one point. Okay, so this green line is a tangent. Okay, so the normal to any tangent. Okay, so what is a normal? So a normal is a line that is perpendicular to the tangent. Okay, so 90 degrees to the tangent, right? So any normal to the tangent will definitely pass through the center of a circle, right? So over here we have a second tangent. This red color line over here is also a tangent. Okay, so this other red line okay, is also normal to the tangent. So this one is a normal, and then this one is a normal. So the normal to any tangent of a circle will definitely pass through the center. Okay, so since these two normals intersect over here, that means this point here has to be the center of the circle, right? So this is one property that you need to keep in mind. Okay, and later on you will see that we'll apply this while doing some fractions. All right. So keep in mind, the normal to any tangent to a circle will pass through the center of a circle, right? Okay, it's important to take note also. If you recall from coordinate geometry, okay, the chapter on coordinate geometry, okay, if two lines are perpendicular, then let's say this is gradient m1 and this normal has gradient m2, then the relationship between the gradient is m1 times m2 equals to -1. Okay, so this is an important relationship that you'll see that you apply very frequently in the questions as well, right? Okay, so let's take a look at the second property, useful property. So any diameter of a circle will pass through the center of a circle, and the midpoint of the diameter is the center of the circle. So any diameter, so let's say these two, this red line and this green line are diameters of a circle, right? Okay, then they will definitely pass through the center of a circle. If it doesn't pass through the center of a circle, then it's not a diameter, right? Okay, and then the next thing is the midpoint of the diameter. Okay, actually I should quantify here. So let's say point A and B okay, are the two ends of this particular diameter of a circle, right? So the midpoint of AB, okay, is going to be the center of the circle. In other words, the center of the circle is going to divide the line AB into two. Okay, so AC is going to be equals to BC, right? Okay, same thing. Let's say this point is P and this is Q. Okay, and it passes through a center, so it's a diameter. So the point C is also going to divide PQ into two. Okay, so this is going to be equal length, right? So this is another thing that you need to take note of, and you will see later on we get to apply this in the O-level question. Okay, then the next useful property is that the perpendicular bisector of a chord will pass through the center of a circle. Okay, so if you recall what is a chord, a chord is a line segment okay, that touches 2 points on the circumference of a circle. So let's say this is A, B, right? So the perpendicular bisector. So what does a perpendicular bisector do? Not only is it perpendicular to the chord, okay, but it cuts the chord into two equal parts. So any perpendicular bisector will definitely pass through the center of the circle. Okay, so this is also another useful property that sometimes you'll find that you need to apply in the question. So if you do not keep in mind this property, then sometimes you find that you get stuck while doing the question. Okay, so keep this in mind. Okay, next one will be a point lies within a circle if its distance from the center is less than the radius of the circle. So what we mean by this is, let's say this is the center of the circle. Okay, then you have a particular point over here. Okay, let's call this P. Okay, if the distance from P to C is less than the radius. Okay, so this is the radius, right? Okay, so radius will be from the center to any point on the a straight line, okay, to any point on the circumference of the circle. Okay, so if the distance, let's say D1, okay, if D1 is less than radius, then the point P will definitely be within the circle. Within the circle means inside the circle. Okay, P within the circle. Okay, the point will be within the circle. Okay, what if it lies on the circle if its distance from the center is equal to the radius? Okay, that means if let's say you have another point Q, okay, over here, and then this distance, let's call it the D2. If D2 is equals to R, okay, then it means that Q lies on the circle. Okay, that means the point Q lies on the circle, right? If the distance to the center is the same as the radius. Okay, then finally it lies outside the circle if its distance from the center is greater than the radius. So let's say we have a third point over here. Okay, let me draw a straight line. Okay, so let's say we have a third point, okay, over here. Okay, let's call this point R. Okay, and call this distance D3. So if D3 is greater than R, okay, then point R lies outside the circle. Okay, so later on you will see that we get to apply this concept as well in the particular O level question. So within one question, we get to apply almost all the concepts, right? Okay, so let's move to the question now. Okay, so a circle C1 has the equation x squared plus y squared plus 4x minus 6y equals to 36. All right. So find the radius and the coordinates of the center of C1. So now we are given the equation of this circle, right? In the general form. Okay. So in the general form, then I think we'll use the 2G2F method. Will be faster. Okay. So if you recall, 2G is the coefficient of x. So 2G will be equals to 4. So this will mean G will be 2, right? Okay, then 2F will be negative 6. So F is going to be negative 3. Okay, so this will mean that the center of the circle is equals to, remember it's minus G minus F. Okay, so minus 2 minus 3, you get negative 2, 3. So this is the center, right? Then we can find the radius. Okay, so remember radius will be G squared plus F squared minus C. Alright, so G squared will be 2 squared plus minus 3 squared, okay, minus C. Okay, so in this case, for this particular question, okay, you got to bring the 36 over to the other side. Okay, so this means that C is negative 36. Okay, so you got to bring it to the other side before you can call it C. All right, so minus C, so minus 36. Right, so from here we get 4 plus 9, okay, plus 36. 4 plus 9 plus 8, 13 plus 36, so you get 49. Right, so square root 49, you get 7 units. Okay, so the radius is 7 units. Okay, so we have made use of the first idea that we discussed today. Okay, how to obtain the center and radius of a circle from the equation of a circle. Okay, in this case, the general form, right? Okay, let's look at part 2 of the question. Okay, second circle C2, so this is a different circle, has diameter AB. Okay, the point A has coordinates negative 5, 5, and the equation of the tangent to C2 at P is 3y equals to 4x minus 15. So in the original question, no diagram is given. Okay, but as mentioned in my other videos on circle, you are strongly encouraged to draw a diagram, okay, to help you to visualize the question better. Okay, I guarantee you it's going to help you to solve the question more successfully. Right, so over here I've drawn the circle and the tangent already. Okay, your diagram doesn't have to be very accurate. Okay, because it only helps you to visualize, but we are not going to solve it using an accurate drawing. Okay, so just rough diagram to do. So basically what I did was I just drew a circle. Okay, it would be good if you can bring your compass and draw a nice circle. Okay, then I draw the tangent up this way. Why is the tangent up this way? Because I can see that the gradient is positive. Okay, if I bring the 3 over, then the gradient will be 4 over 3. So it's a positive gradient. All right. Okay, so over here is tangent to the circle at point B. That means this is point B. All right. Okay, then AB is the diameter of a circle. So that means over at the other side, we have point A that is coordinates is minus 5, 5. Right. So that means the center has to be here, right? Because remember what we mentioned just now. Okay, the center diameter of circle will definitely pass through the center. Okay, now they want us to find the equation of diameter AB. So to find the equation of a line, we need to know two things. Okay, we need to know firstly the gradient of the line. Okay, so do we know the gradient of AB? Okay, secondly, one point that passes through. Okay, this one we already know, right? Because it passes through A, minus 5, 5. Okay, so the coordinates of one point that passes through. So we already know this. Now we just need to find the gradient of AB. Right, so let's think about the ideas that we mentioned just now. Just now before, besides mentioning that the diameter of a circle will definitely pass through the center. Okay, we also mentioned that the normal to any tangent, right, will definitely pass through the center. Okay, so now we are going to use the reverse argument. If the normal passes through the center, okay, what can we say about this diameter and this tangent? Okay, they have to be perpendicular to each other, right? Okay, because if they are not perpendicular, then this diameter shouldn't pass through the center, right? And moreover, you also learn this property called tangent perpendicular to radius. Okay, so CB is now the radius also, right? Okay, BC is also the radius. Okay, so the radius will be perpendicular to the tangent. Okay, and this is an important thing in order to allow us to find the gradient of AB, right? Okay, so since AB is perpendicular to the tangent, then when you multiply the product of their gradients, then you should get -1. Okay, so we are going to make use of that to find the gradient of AB. Okay, so let's start with the working. So let's call this gradient of tangent. So the gradient of tangent at B will be 4/3, right? Okay, so how do we obtain 4/3? Okay, basically you just make y the subject. So 3y equals to 4x minus 15, right? So make y the subject. Okay, so basically you put the equation on line y equals to mx plus c form. So this 4/3 will be the m. Okay, so it's a gradient. Okay, so the gradient of AB, okay, since it's perpendicular to the tangent, times the gradient of the tangent will give you -1. So this means that the gradient of AB is -3/4. Okay, and this will allow us to find the equation of AB. Okay, so we are going to use y minus y1 equals to mx minus x1. Okay, so y minus, okay, remember it must be a point that lies on the line AB. Okay, so y minus y1, so y1, x1, y1 is now the coordinates of A. X minus x1, alright? Okay, so let's expand out first. Let me write this properly. Okay, so if I expand this, so -3/4 times +5, so you get -15/4, right? Okay, so just bring the 5 over. Okay, 5 is 20/4, so you just get +5/4. Okay, so this will be the answer for the equation of the diameter of AB. Okay, next thing they want us to do is find the coordinates of B. Right, so we have found this equation to be -3/4x plus 5/4. Right. Okay, so if you want to multiply throughout, you can do it. Okay. If not, multiply throughout by 4, you can do it. But if not, you can leave it in this form. Right. So now, if you look at, they want us to find the coordinates of B next. So if you look at B, B lies on the line AB and also lies on the tangent. Okay, so whenever you want to find a point that lies on two lines, okay, it's basically finding the intersection point of those two lines, right? So the moment you think come across the word intersection point, what should come to mind? Yes, okay, to solve simultaneous equation. All right. Okay, so we will solve simultaneous equation for the equation of AB as well as the equation of the tangent. All right. So we have expressed the equation of tangent. We can write in this form also. -5. So let's call this equation 2. Okay, so we will equate 1 and 2, and then when we solve it, we should be able to get the coordinates of B. Right, so let's do it over here. So equate 1 and 2. Alright, so if we equate 1 and 2, we will get -3/4x plus 5/4 equals to 4/3x minus 5. Alright. Okay, so we'll bring all the x terms to one side. Okay, so if I bring the 4/3 to the other side, so I will get this 3x, then I'll bring the -5/4 to this side. Alright, so from here we'll continue here. So you should get negative 25 over 12x equals to negative 25 over 4. Right, so if you divide over, okay, you should get x equals to 3. Okay, then you will sub x equals to 3 into probably equation 2. Okay, will be easier. So you get 4 over 3 times 3 minus 5. Okay, so it's 4 minus 5, you will get negative 1. Okay, so the coordinates of b will be 3, negative 1. Okay, so b will be 3, negative 1. Okay, so once you find, you can actually write inside the diagram, right? Right, let's look at part 3 of the question. Okay, so find the radius and the coordinates of the center of C2. Okay, so to find the radius and the coordinates of the center of C2, okay, you need to think about the ideas that we discussed earlier. Okay, so if you remember, one of the ideas that we discussed was that the midpoint of any diameter, okay, of at the two endpoints of a diameter of a circle will give you the center. Okay, so in other words, we can find the coordinates of the center of C2 very easily by just finding the midpoint of AB. Okay, so let's do that. Okay, so I'll write the working here. So center of C2 equals to midpoint of AB. Okay, if you recall, the midpoint is very easily found. We just add up the two x coordinates, divide by 2, add up the two y coordinates, divide by 2. Okay. Okay, so you should be able to get negative 1 over here and then 2 over here, right? Okay, so the center C2 will be negative 1, 2. Okay, then to find the radius would be very easy as well. All we need to do is find the distance from the center to either point A or point B. Okay, because from the distance from center to any point on the circumference, okay, will give you the radius. Right? So let's use point B and point C. Okay, so the radius is equals to square root. Okay, so to find distance between 2 points, we are going to use x1 minus x2 square plus y1 minus y2 square is square root the whole thing. Okay, so you can watch my video on coordinate geometry where I go through all these other concepts. Okay, so minus 1, okay, minus 3 square. Okay, so I'm using this one minus this one, okay, plus 2, okay, this one minus this one, okay, 2 minus 1 square. Right, so if you add up, okay, you will get negative 4 square, which will be 16. 3 square, which will be 9. So square root 25, so you get 5 units. Right. Okay, so this is how you find the center and radius of a circle. Okay, when you have 2 endpoints at the on the diameter. Okay, the last one will be the idea that we discussed just now. Okay, how to decide whether a point lies within the circle, on the circle, or outside the circle. So explain why the point 4, 6 lies within only one of the circles. So basically, we are going to find the distance from the point 4, 6 to the center of both circles and then compare it to their radius. Okay, so let's do that. Okay, so distance of 4, 6 to center of C1. Right, so the center of C1, if you go back all the way here, is minus 2, 3. Okay, minus 2, 3. Okay, so we are going to find the distance from 4, 6 to minus 2, 3. Okay, so same thing, use the distance from formula. So okay, so go refer okay to the question. Okay, so you will get 6.71 units. Okay, and if you recall just now the radius of C1, okay, the radius of C1 is actually 7 units. Okay, over here 7 units. Okay, so it's less than the radius of C1. Okay, so what you can write is since 6.71 units is less than 7, right? Okay, which is the radius of C1. Okay, 4, 6 lies within C1. Okay. Okay, then next one, let's do it for the second circle. Distance of 4, 6 to center of C2. So the center of C2 we obtained just now, minus 1, 2, right? Okay, so let's do that. Plus 2 minus 6 square. So it's 6.40 units. Okay, but be careful. C2 has a different radius. Okay, C2 radius only 5. Okay, since 6.40 units, okay, is greater than 5, so which is the radius of C2. Okay, 4, 6 lies outside C2. Okay. Okay, so since it lies within C1 but outside C2, so it only lies within one of the circles. Okay, so hence 4, 6 only lies within C1. Okay. Okay, so this is how you apply the concepts of circles. Okay, so overall not too difficult. So this is a question from the 2014 O-level paper 2 question 10. Right? Okay, so I hope that this video is useful for you and help you to recap some of the concepts regarding circles.